Hopefully everybody can hear the sound, and if they're not hearing the sound, they're reading this sign and getting the sound working. This is a lesson out of the Geometry Chapter 4 Study Guide on Section 412, which is Chapter 4, Section 1, Part 2. So, in this section, we're largely using the triangle sum theorem, which basically most students, by the time they get into geometry, have already seen several times before. It simply says that when we add up the angles inside a triangle, if we add corner A plus corner B plus corner C, their degree total would be 180 degrees. So we can use this theorem to find things that we don't know. Now, so far in math, you've probably been given degrees that you are familiar with, but today we're going to be working in some variables like x's and y's and so forth, and have you think a little bit more about how we could use the theorem algebraically. So for example, number 11 has three angles. One is 90 degrees, one is 2x degrees, and one is x degrees. According to this triangle sum theorem, if we add the three of them together, the grand total is 180 degrees. So if I do some consolidating here, 2x plus 1x is 3x, I can solve for x and find the value of x. So I'll subtract 90 on both sides, and then divide both sides by 3. Oops. So I get that x equals 30. Okay. Now not only do they want us to find the value of x, but they would also like us to classify the triangle by its angles. Okay, so we've got some options here. I go back to section 411. Classifying a triangle by its angles, we have four choices: equiangular, obtuse, right, and acute. So let's actually figure out the values of each one of these angles, and that'll be more helpful. So this one's 90, this one would be 2 times 30, which is 60, and this one would be just 30. Now, this one's not that hard because I can see there's a right angle. Bingo, that's just a right triangle. Number 12. Using the same basic setup where I add 3 interior angles together and I get a total of 180 degrees, I can solve for x by solving the equation. Okay, so x equals 25. What kind of triangle is this based on its angle? Well, I don't know what these angles are yet, so let's see. 25 times 2 would make this corner a 50-degree corner, and 25 times 3 would make this a 75-degree corner. Do you see any right angles here? 90 degrees? No, so it's not a right triangle. Do I have all 3 angles the same? No. One is 75, one is 55, and one is 50, so it's not equiangular. So these two are out. So it's either got to be obtuse or acute. An obtuse triangle has one angle that's bigger than 90 degrees. So is there an angle here that's larger than 90 degrees? No. So it must be this last one, an acute triangle. Acute triangles have all 3 angles that are smaller than 90 degrees. So, yes, that's what it is. Acute. All right. The exterior angle theorem. It says that if you have an exterior angle, for example, this one here, angle 1, it's actually going to be equal in measure to the sum of the two angles on the inside of the triangle that are farthest away, which would be this one and this one. Okay, so you can see that angle 1 is an exterior angle formed at vertex C, and then the two interior angles that are farthest away would be B and A. Non-adjacent. Adjacent means next to, and to be not adjacent would be not next to. So as you can see, this is an exterior angle. The one that would be next to this on the inside would be this one here, but we want the interior angles that are not next to it, which would be the other two. So angle 1 is the same as adding the measures of angle A plus angle B on the inside. So here's an example of how we could use that. Number 13 is an exterior angle, and these two here are interior angles that are farthest away from it. So angle X, the exterior angle, would be the same as the two interior angles farthest away added together. So X equals 120 degrees. This diagram isn't perfect. This is supposed to be an X here in the corner. So here's the exterior angle, right? And the interior angles that are farthest away would be 73 and X. So 3x minus 9 is the exterior angle. If we add up the two interior angles farther away, not this one, the other two, we have an equation. And this can be solved for x, but that's not actually what they want us to find. If we read the directions carefully, they actually want us to find the measure of angle DCB. That's this one. So x is not our answer. We need to take that value, substitute it in for x here, and actually find the measure of angle DCB. Make sure you answer the entire question. Don't just stop halfway because you think that's all they want. Okay. So I'm just going to do some equation solving here. Okay, so I get a value of x of 41. All right, now if I want to find the measure of angle DCB, we have an expression that represents it at the moment, and that's 3x minus 9. But if we want to find the actual number of degrees that it measures, we'll have to substitute the number 41 in for x. Now that we know the value of x, we have 123 minus 9, or 114 degrees. It looks like an angle that would be bigger than 90 just by a little bit, so that makes sense that this is 114 degrees. Okay, I'm just going to do the top 3 examples on this page. Number 14. Okay. Number 14 says, hey, here's an exterior angle that we've labeled right here. And here are the two interior angles that are farthest away, 80 degrees and x degrees. Okay, so we can use our exterior angle theorem to find the value of x, and then they want us to find the measure of the exterior angle, which is this one. So just as in the last example, we're going to be doing kind of a two-step process. First we'll find the value of x, and then we'll find the thing they're asking us to do, to find, is the measure of the exterior angle, which would be this one right here. So the exterior angle is equal to the sum of the two farthest away interior angles, x and 80. So solving here, like a regular equation for x, I get an x value of 51. Now, to find the measure of this angle, we would go back up here and we would say that that algebraic expression that represents the angle measure is 3x minus 22. Our x value is now known, so we can use that to find our final answer. 3 times 51 is 153. Minus 22 is 131 degrees. So that is my final answer for number 14. This was part of getting to that answer, but that wasn't my final answer. Number 15, the exterior angle is here, right there. And the two interior angles are here and here, right? So my exterior angle, 4x plus 8, is equal in measure to the sum of the two farthest away interior angles. So that would be 2x plus 3 added to the other angle, which is 51. So my first phase of solving would be to solve for x. Solve it as an equation. Okay, so we have a value of x of 23, and we want to find the value of the entire exterior angle in degrees. So we have an expression for that. It's 4x plus 8. So now that we know our x value, it's no longer unknown, we can substitute that into the equation, or into the expression here, and we have 92 plus 8, or 100 degrees. Again, that makes sense. It looks to me like in the diagram that this angle right here is, again, a little bit bigger than 90 degrees, so that would be 100 degrees. Yeah, that makes sense. And then finally the last one here, we have an exterior angle down here, and two interior angles, one right here and one right here. So the exterior angle, 6x minus 7, would be equal to the sum of these two. So it would be equal to the 2x plus 103 minus x. So if I do a little simplifying, I can add 2x to the negative x and get 1x. Add like terms on the same side. Then I'm going to subtract 1x on both sides, so I get 5x minus 7 equals 103. And then if I add 7 on both sides, I get 5x equals 110. And then finally, dividing both sides by 5, I get x equals 27. So, or not 27, 22. Okay, so now when I have our x value, they want us to find the value of the exterior angle. So, I'm going to write that up here. There we go. So our exterior angle is 6x minus 7. But as an actual measure in degrees, we can find that by substituting our value for x in. And 6 times 22 is 132. And then if I subtract 7, I get 125. And then the last thing I was going to mention for this lesson is that there's this theorem that's pretty much the same as the exterior angle theorem that says that if you have an exterior angle, it's going to add up to the sum of the farther away interior angles. This one actually, oh, I'm sorry. This one is a corollary on the just the basic triangle sum theorem that says that if you add the three interior angles, that add up to 180. Okay, so here we basically say that, hey, if we're going to add corner A plus corner B plus corner C and it adds up to 180, if the triangle's a right triangle, then we know that 90 degrees out of that 180 is already taken up. And so since we know that 90 degrees must be equal to 90 degrees, meaning that 90 and 90, these two together must be 90 because this one is 90. And all three of them then add up to 180. I'm actually going to rewrite what I was trying to say down here. So angle C is 90, these two together, A plus B, then would have to be 90 because 90 plus 90 gives you an interior sum of the three of them to be 180. So it turns out that the acute angles, that's these two, on a right triangle are, I'm just going to change this to add up to 90 degrees. And in math we have a word for that. It's called being complementary when two angles add up to 90 degrees. So just a quick example with that, for this triangle right here, you can see that if this is 90 degrees, then this angle in here would also be 90, right? So for this triangle that I'm circling, it has three angles. It has this 90-degree corner, and then it has these other two. So the other two angles would have to add up to, if I was trying to find this corner up here, let's call it, not X, let's call it W, okay? If I wanted to find corner W, I could say that W plus 30 would have to equal 90. These two interior angles, if it's a right triangle, the other two smaller angles called acute angles have to add up to 90. So W would be 60 degrees. That's how I might apply the corollary at the bottom of the page.